Hey everyone, and welcome. Have you ever wanted to know the temperature in your workshop or maybe check the humidity in your greenhouse without actually going there? Well, today that's exactly what we're going to build. We are taking this tiny little ESP32 chip and turning it into a full-blown web server that shows live sensor data. So let's dive in. And this is what we're aiming for. A super clean, simple web page that you can pull up on your phone or computer showing you the real-time readings. But here's the best part. It's not a static page. It's going to update automatically every few seconds, so you're always looking at the very latest data. Pretty cool, right? So that begs the question, how in the world do we get this tiny little chip to act like a web server, serving up a live web page? I know it sounds like it might be complicated, but you're about to see just how surprisingly simple it really is. We're going to break this down into 4 easy parts. First, we'll talk about what we're building and the gear you'll need. Then we'll get our hands dirty and wire it all up. After that, we'll jump into the software side of things. And finally, we'll get it connected to your network and see our live data page in action. All right, first things first. Let's gather all the pieces we need for our little web server project. The shopping list is really short and sweet. You need an ESP32 board. That's the brains of the whole operation. For the sensor, you can grab either a DHT11 or a DH22. Don't worry, the setup is exactly the same for both. And then you'll just need a breadboard, a few little jumper wires to connect everything, and of course a USB cable to give it power and upload our code. Okay, now for the hardware. This part is going to be quick, I promise. It's literally just connecting 3 little wires. Yep, just 3 connections. First up is power. The sensor's VCC pin hooks up to the 5-volt pin on the ESP32. Easy enough. Second, we need a ground connection, so the GND pin on the sensor goes to any GND pin on the ESP32. And last, the important one, the data pin. This is what sends the actual readings, and we're going to connect it to GPIO pin 26. And if you're wondering, GPIO just stands for General Purpose Input-Output. It's just a pin we can use for stuff like this. With the hardware all wired up, it's time for section 3, the software. This is where we use the Arduino IDE to tell the ESP32 what we want it to do. Now, before we even look at the code, we got to talk about libraries. Think of them as like little pre-made toolkits or cheat sheets that add new abilities to our project. The good news is the libraries we need to handle Wi-Fi and act as a web server are already built in. We just need to add one more so our code knows how to talk to our DHT sensor. And adding it is so easy. In your Arduino IDE, you just go to the library manager, type in DHT sensor library in the search bar, find the one with that exact name, and hit install. And that's it. Your code now has the superpower to read from that sensor. Okay, let's look at the code itself. And believe it or not, you only have to change 2 things. This is the most critical part. You have to give the ESP32 your Wi-Fi network's name, that's the SSID, and of course the password. Just swap out these placeholders with your own network credentials. The only other things you'll want to double check are right here. Make sure the GPIO pin number in the code, 26 in our case, matches the physical pin you actually used. And then just tell it what kind of sensor you have, whether it's a DHT11 or a DHT22. This is just to make sure the software and hardware are on the same page. All right, our hardware is wired up, our software is configured. It's time for the final and most exciting step. Let's get this thing online and actually see our live web page. To get the code onto the chip, you'll first select your specific ESP32 board model and the right COM port. That's just the channel your computer uses to talk to it. Then you hit the upload button. Now, here's a super important tip. When you see the message connecting in the console at the bottom, you need to press and hold the little boot button on the board itself. This tells the ESP32 it's ready to receive new code. Once the upload is done, we need to figure out our server's address. So, open up the serial monitor in the Arduino IDE. Make sure the baud rate, which is just the communication speed, is set to 115200. The ESP32 will connect to your Wi-Fi, and then, boom, it'll print its IP address right there for you. It'll be a number that looks something like this. You can think of this as the unique street address for your new web server on your home network. You can type this number into the web browser of any phone, tablet, or computer that's on the same Wi-Fi network. But there's a catch. This IP address is usually given out by your router, and it can change every single time you unplug and restart your device. And trust me, having to open the serial monitor just to find the new IP address every time will get old really fast. But luckily for us, our code has a super elegant solution for this problem. It uses a library called ESP32. Basically, this library lets us give our server a nice, permanent,
easy to remember name, so we don't have to mess with those changing IP addresses ever again.
And that name is ESP32.local. That's it. Because of that MDNS library, you can now just type ESP32.local into your browser. It's way easier to remember, and it will just work every time, as long as you're on the same network.
Oh, and one last awesome feature to point out. Remember how I said the data is live? That's because there's a tiny snippet in the HTML code that tells your browser, hey, refresh this page every 4 seconds. This is what keeps the data fresh and makes sure you're always looking at the most current readings.
And that's it. Mission accomplished. Let's just step back for a second. In just a few minutes, you've built a web server, you've got it displaying live data from a sensor, and it's accessible from any device on your Wi-Fi network using a simple, memorable name. That's seriously impressive. And that really gets you thinking, right? Now that you have this power, temperature and humidity are just the beginning. Imagine connecting sensors for light, for motion, for air pressure, anything. So the real question is, what kind of data are you going to display on your web server?